Sodium hydroxide. Preparation. Sodium hydroxide is prepared by passing electricity through an aqueous solution of sodium chloride, brine, in a specially designed cell. As a result of electrolysis, chlorine gas is given off at anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. To NaCl, sodium chloride reacts with water 2H2O, giving 2NaOH, sodium hydroxide, chlorine Cl2 and hydrogen H2. This process is known as chlor-alkali process. Properties of sodium hydroxide. Sodium hydroxide is a white, translucent solid. It melts at 591 Kelvin. It is readily soluble in water to give a strongly alkaline solution. Crystals of sodium hydroxide are deliquescent. Uses of sodium hydroxide. Sodium hydroxide is used in the manufacture of soaps, detergents, paper and artificial silk. It is used for degreasing metals and for purification of bauxite.
Baking soda. Preparation. The soda commonly used in the kitchen for making tasty crispy pakoras is baking soda. The chemical name of the baking soda is sodium hydrogen carbonate, NaHCl3. Sometimes it is added for faster cooking. It is prepared from the sodium chloride. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCl3. Uses. Sodium hydrogen carbonate is used for making baking powder. Used as an ingredient in antacids, neutralizes excess acid in the stomach and provides relief. Used in soda acid, fire extinguishers. Washing soda. Preparation. The chemical name of the washing soda is sodium carbonate. It is prepared by heating baking soda. The recrystallization of sodium carbonate gives washing soda. Na2CO3 plus 10H2O gives Na2CO3 10H2O. Uses. Used in glass, soap and paper industries. Used in the manufacture of a borax. Used as a cleaning agent for domestic purposes. Used for removing permanent hardness of water.
Preparation of washing soda and baking soda. Washing soda and baking soda are two commonly used compounds of sodium. Chemically, washing soda is sodium carbonate decahydrate with the chemical formula Na2CO310H2O. Baking soda is sodium bicarbonate, NaHCO3. In the laboratory, they can be prepared taking caustic soda, NaOH, as the raw material. The apparatus required for the preparation of washing soda and baking soda is arranged as shown here. Limestone, CaCO3, is taken in a flat-bottom flask. Caustic soda solution is taken in a large test tube. Dilute hydrochloric acid is dropped into the flask through the thistle funnel. Limestone and dilute hydrochloric acid react to generate carbon dioxide gas. Carbon dioxide gas is passed through water to remove the unreacted hydrochloric acid. The gas is now passed through concentrated sodium hydroxide solution till a white solid appears at the bottom of the boiling tube. The white solid formed is sodium carbonate, which is insoluble in water. When excess of carbon dioxide is passed through sodium carbonate, it gets converted to sodium hydrogen carbonate. Sodium hydrogen carbonate, being sparingly soluble in water, can be filtered off to separate it from water. This is the laboratory method for the preparation of sodium hydrogen carbonate. Sodium carbonate can be obtained by heating sodium hydrogen carbonate. Sodium carbonate so formed is dissolved in hot water and heated to crystallization point. Crystals of sodium carbonate decahydrate or washing soda are obtained by cooling.
To know if the crystals of salts are really dry, let's perform a quick experiment. All we would need for this experiment is a burner, a test tube and a test tube holder. We would also need a few crystals of copper sulfate. Before we begin our experiment, could you tell me the color of the crystals? Yes, it's blue. The crystals look dry, don't they? But are they really dry? Let's find out. Now let's add these crystals in this dry test tube and heat it. What do you notice after some time? You notice that the color of the crystals turn grayish white. And did you observe the water droplets on the test tube? Why does this happen? It's because when copper sulfate is heated, it loses its water molecules. And that's why it turns grayish white in color. When it's dry, it's referred to as anhydrous copper sulfate. And what do you think will happen when we add water to it again? After adding water to anhydrous copper sulfate, it becomes blue again. The chemical formula for hydrated copper sulfate is CuSO4.5H2O. Yes, there are 5 water molecules you can see. This water is called the water of crystallization. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. So we can say that 5 water molecules are present in one formula unit of copper sulfate. And when heated, it loses its water molecules. Another example is that of ferrous sulfate. It has a green color due to the presence of 7 water molecules in it. So though the crystals look dry, they aren't really dry. Another salt which possesses water of crystallization is gypsum. It's a hydrated salt of calcium and its chemical formula is CaSO4.2H2O. What is it used for? When we heat gypsum at 373 Kelvin, it loses its water molecules to give us plaster of Paris. Have you heard of plaster of Paris before? Yes, it's a substance which doctors use as a support for fractured bones. It's also used in the construction industry and in making casts for statues, and also making designer false ceilings. Its chemical name is calcium sulfate hemihydrate and its chemical formula is this: CaSO4 and half a molecule of water. After addition of water, plaster of Paris is again converted into gypsum. Okay, are you wondering how we are able to see just half a water molecule here? Is that possible? It's written like this because 2 formula units of calcium sulfate share 1 water molecule. And why do you think it's called plaster of Paris? Does it have anything to do with the city named Paris in France? Plaster of Paris was first made many years ago and has been used by ancient Egyptian and Roman civilizations. However, it wasn't used on a large scale until the 17th century, when it was required to be used in almost all the construction in Paris. In the year 1666, a fire raged across London, destroying many parts of it. In its aftermath, the King of France ordered that all walls made of wood in Paris be immediately covered with plaster as a protection against such fires. This resulted in large-scale mining of gypsum, which was available around Paris in huge quantities. Thus, during the early 18th century, Paris became the center of plaster production, and hence the name Plaster of Paris.